There are places in our universe that break the laws of physics, and they're real. For decades, scientists believed they had the universe figured out. Gravity, dark matter, the Big Bang, everything seemed to follow predictable patterns. But then we found them. Regions so strange, so impossible, that they shouldn't exist according to everything we know. Voids where galaxies vanish. Structures too massive to form. Cold spots that hint at collisions with other universes. Today, we're diving into 5 cosmic anomalies that are rewriting the rules of reality. If you're ready to have your mind blown, hit that like button and subscribe. Because by the end of this video, you'll never look at the night sky the same way again. Imagine staring at a map of the universe and finding a hole. Not just any hole, a void so vast, so empty, that it spans 330 million light-years across. This is the Boat's void, and it's one of the most unsettling discoveries in modern astronomy. Here's the problem. The universe shouldn't have deserts like this. According to our models of cosmic evolution, matter should be distributed relatively evenly after the Big Bang. Galaxies should cluster. Yes, but they should never leave behind such massive empty spaces. Yet the Boat's void contains only about 60 galaxies. To put that in perspective, a normal region of space this size would contain roughly 10,000 galaxies. When astronomers first discovered it in 1981, they thought it was an error. They rechecked their instruments, recalculated their data, and searched again. The void remained. It was real, and it was enormous. So what could create such an impossible emptiness? Some scientists suggest that dark matter might have clumped differently in this region, pushing galaxies outward. Others propose that we're witnessing the aftermath of an ancient cosmic event we don't yet understand. The truth is, we simply don't know. To grasp the scale we're dealing with, imagine our entire Milky Way galaxy as a single grain of sand. The Boat's void would be like finding a beach-sized empty space where no grains exist at all. It's not just empty, it's wrong. But if you think a cosmic desert is strange, the next anomaly takes things to an entirely different level. In 2004, scientists analyzing the cosmic microwave background, the ancient light left over from the Big Bang, noticed something that made them question everything. There was a spot, a cold spot, and it was massive. The cosmic microwave background, or CMB, is essentially a baby picture of our universe, taken when it was only 380,000 years old. It should be almost perfectly uniform, with only tiny temperature fluctuations across the entire sky. These fluctuations are predictable, understood, and fit neatly into our models of how the universe evolved, except for this one region. The cold spot is about 1.8 billion light-years across, and it's significantly colder than it has any right to be. We're talking about a temperature difference that's so statistically improbable, it should occur less than once in every 100,000 simulated universes. Yet there it is, staring back at us from the edge of observable space. Scientists initially dismissed it as a measurement error or cosmic coincidence, but multiple satellites and instruments have confirmed it. The cold spot is real, and none of our current theories can fully explain it. The implications are staggering. Some physicists suggest it could be evidence of another universe, a parallel reality that collided with ours in the early moments after the Big Bang, leaving behind this cosmic bruise. Others think it might point to a supervoid, an even larger empty region pulling energy away from that patch of sky. What makes this truly unsettling is what it means for our understanding of the Big Bang itself. If the cold spot exists, then either our models are incomplete, or something truly bizarre happened in the first moments of cosmic history. And speaking of things that shouldn't exist at cosmic scales, our next anomaly makes the cold spot look almost small. What's the largest thing that can exist in the universe? According to the laws of physics, there's actually a limit. The cosmological principle, one of the foundational ideas in modern astronomy, states that on large enough scales, the universe should look roughly the same everywhere. Matter should be distributed evenly. No structure should be so massive that it breaks this cosmic balance. The Hercules Corona Borealis Great Wall doesn't care about that rule. Discovered in 2013. This structure is a galactic filament so monumentally large that it spans approximately 10 billion light-years across. To put that in perspective, light itself traveling at 186,000 miles per second would take 10 billion years just to cross from one end to the other. It's the largest known structure in the observable universe. Here's why this is a problem. According to our calculations, structures larger than about 1.2 billion light-years shouldn't be able to form. The universe simply hasn't existed long enough for gravity to pull together something this massive. It violates our theoretical size limit by a factor of nearly 10. When astronomers plot the distribution of gamma-ray bursts across the sky, they found these distant explosions clustering in a pattern that revealed the Great Wall's existence. At first, they couldn't believe the data. They ran the numbers again and again, hoping to find an error. There was none. This discovery forces us to confront an uncomfortable truth. Either our understanding of how cosmic structures form is fundamentally flawed, or something about the early universe worked very differently than we thought. Imagine building a sandcastle and discovering that one grain of sand is somehow the size of a boulder. That's essentially what we're dealing with here, a cosmic structure that has no business existing at this scale. But at least the Great Wall is something we can observe and measure. Our next phenomenon exists only in the equations of physics, yet its absence might be even more troubling. Everyone knows about black holes, cosmic monsters that devour everything, even light itself. Their gravity is so intense that nothing can escape once it crosses the event horizon. They're terrifying, fascinating, and very real. We've photographed them, detected their gravitational waves, and watched stars orbit around them. But physics has a strange quirk for every black hole crushing matter into oblivion. The mathematics suggests there should be a white hole doing the exact opposite. White holes are the theoretical mirror image of black holes. Instead of pulling everything in, they would violently expel matter and energy outward. Nothing could ever enter a white hole. Its event horizon would act as a one-way barrier, pushing everything away. It's like a cosmic fountain, endlessly spewing out matter and light. The equations of general relativity not only allow white holes to exist, they practically demand them. Einstein's field equations are time-reversible, meaning if you can have a region of space-time that pulls everything in, you should also be able to have one that pushes everything out. Mathematically, they're just as valid as black holes. So here's the mystery. If the math says white holes should exist, where are they? We've scoured the cosmos and found nothing. No observations, no evidence, no unexplained sources of matter violently erupting into space. Some scientists argue that white holes might have existed only in the earliest moments of the universe, perhaps even serving as the other end of black holes in some cosmic recycling system. Others suggest they're inherently unstable and would collapse instantly if they ever formed. The most unsettling possibility: they do exist, but we simply don't recognize them when we see them. Perhaps certain cosmic phenomena we've already observed, like quasars or gamma-ray bursts, are actually white holes in disguise, and we just haven't realized it yet. What makes this absence so haunting is the question it raises. If the universe follows the laws of physics, why would it choose to create black holes but not their opposite? Is there something we're missing about how reality actually works? And speaking of things that challenge our assumptions about reality itself, our final anomaly strikes at the very heart of where we are in the cosmos. For centuries, humanity has operated under a comforting assumption: we're not special. Earth isn't the center of the solar system. Our sun is just one of billions. Our galaxy is ordinary. Our location in the universe is completely unremarkable. This idea, called the Copernican principle, has guided astronomy since we stopped believing the cosmos revolved around us. Then we found the axis of evil, and suddenly that assumption started to crack. When scientists mapped the cosmic microwave background in exquisite detail, they expected to find random temperature fluctuations scattered across the sky with no particular pattern. What they found instead was deeply disturbing. Certain large-scale patterns in the CMB weren't random at all. They were aligned. Specifically, they were aligned with the plane of our solar system and the equinox of Earth. This alignment is so statistically improbable that physicist Joe Maguire called it the axis of evil, a tongue-in-cheek name that stuck because of how profoundly it disturbs our cosmological assumptions. Think about what this means. The CMB is light from the edge of the observable universe, emitted nearly 14 billion years ago, long before our solar system even existed. It should should have absolutely nothing to do with Earth's orientation or our position in space. Finding a connection between these ancient cosmic patterns and our tiny planetary system is like shuffling a deck of cards and having them arrange themselves to point directly at you. Scientists have worked frantically to explain this away. Maybe it's an instrumental artifact, something wrong with our satellites or telescopes. But multiple independent observations from different spacecraft have confirmed the alignment. Maybe it's contamination from our own galaxy. But after filtering out every known source of interference, the axis persists. The most unsettling explanation is also the simplest. What if our location in the universe actually is special? What if the Copernican principle, this bedrock assumption of modern cosmology, is wrong? Most scientists refuse to accept this possibility. It would overturn centuries of astronomical understanding and raise uncomfortable questions about why the universe would care about our particular position. Yet the data remains, stubbornly pointing back at us like an accusation we can't answer. These cosmic anomalies, from impossible voids to theoretical white holes to patterns that seem to know we're watching, they all tell us the same thing. So what do all these cosmic anomalies tell us? They reveal something profound about the nature of knowledge itself. Every scientific theory we hold dear, from the Big Bang to general relativity, is built on observation of a universe that keeps surprising us. These impossible regions aren't errors or glitches in our instruments. They're messages written in the fabric of space-time, telling us that reality is far stranger than our equations suggest. The boat's void reminds us that emptiness can be just as mysterious as matter. The cold spot whispers of universes beyond our own, colliding in ways we're only beginning to imagine. The Hercules Corona Borealis Great Wall stands as a monument to structures that shouldn't have had time to form. White holes exist perfectly in our mathematics but refuse to appear in our telescopes, forcing us to question whether math alone can predict reality and the axis of evil. It dares us to wonder if perhaps, just perhaps, our position in the cosmos isn't as random as we'd like to believe. What's remarkable isn't just that these phenomena exist, it's that we're humble enough to admit we don't understand them. A century ago, we might have forced these observations to fit our theories or dismissed them as impossible. Today, we're learning to sit with the discomfort of not knowing. This is the frontier of human knowledge, not the confident declarations of textbooks, but the quiet uncertainty of scientists staring at data that refuses to make sense. It's here, in these impossible places, where the next revolution in physics is waiting to be born. Every one of these cosmic mysteries reminds us that the universe doesn't care about our theories, our models, or our need for everything to fit neatly into categories. It simply exists in all its bizarre, contradictory, magnificent glory. And perhaps that's exactly how it should be. After all, a universe that made perfect sense would be a universe hardly worth exploring. So we've journeyed through voids that shouldn't be empty, cold spots that hint at colliding universes, structures too massive to exist, theoretical objects that refuse to appear, and cosmic patterns that seem to point directly at us. 5 regions of space that challenge everything we thought we knew. Which of these cosmic mysteries fascinated you the most? Are you Team Boat's Void, or does the axis of evil keep you up at night? Let me know in the comments below. I read every single one, and I love hearing your theories. If you want to dive even deeper into the strange physics of black holes and what might exist beyond their event horizons, check out the video I've linked in the description. And if this journey through impossible space expanded your mind even a little bit, do me a favor, hit that subscribe button and turn on notifications. We're exploring the edges of human knowledge here, and trust me, there are plenty more cosmic mysteries waiting to blow your mind. The universe is full of impossible places, contradictions that shouldn't exist, and phenomena that laugh at our attempts to understand them. And that's exactly what makes it worth exploring. Thanks for watching, and I'll see you in the next one.